Hi, I'm Nat.
And I'm Lo.
And this is our 20% project, where we go find out about different Google stuff we're curious about.
Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning.
Since then, we've been kind of fascinated by it.
So today, we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it, but for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting.
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos.
Here are all my dog photos.
Here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we would just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Whew. Whew.
So, researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn.
But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. and it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, you know, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, you know, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you know, you say to a kid, you know, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not gonna be like, shoe, right? You know.
Well, like, the more you describe this, the more I'm amazed by human beings.
Yeah.
Like,
yeah.
the effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
Oh.